everyone. Welcome to everyone. I'm Sana from class 10 and I'm part of this institution from last 3 years, and today I'm in front of you to present a seminar on a very interesting but everyone feel a bit difficult topic to understand. It is reflection of light, and today I'm going to explain you in such a manner that it will be easy for you to understand. So let me start with explaining or asking a question to you. How do we perceive things around us? It's a bit normal question, but let me tell you. There we have 5 senses: sight, sight, smell, hearing, response to simple stimuli, and etc. But you know, there's one fact: 80% of the world around us we perceive by our sight. So we can say that eyes are the most important senses of all. So now, if we take an example, let me ask you one more question. How do we see objects around us? There have been many theories from many years. Like one theory says that light rays come from our eyes, hit the objects, and get reflected back, and thus we are able to see the world. So is that right? As we know today, that's not the good or not. That's not the rightest candle of cake. But the answer to this question is light. So let me explain you. If we consider a source of light over here, the best source for the light is sun. Rays from the sun incident on any object. The object reflects the rays back, and thus we are able to see. So there are many objects which allows or generate their own light. Such objects are known as luminous objects. The best example for the luminous object is sun. Luminous objects they generate or they possess their own light, and vice versa, non-luminous objects. They are the objects which do not generate or possess their own light. Best example for this can be anything like a chair, table, or anything. So this was all about the source of light and a clear idea for the light. Let's move ahead. So there are many positions of the objects, right? Most position can be at infinity, which is sun, and we can classify light in many ways. You have been coming across the word propagation of light, rectilinear propagation of light. So you have been studying that light always travels in a straight line. But now, when we come in the 10th standard, there have been many theories that consider light as a wave, light as a particle. So there's not a fixed theory for light. Mainly it is divided into a wave theory and a particle theory. So what wave theory tells us, it mainly gives basic idea for other theories like differentiation, then polarization, and many other. And when we consider light as a particle, there can be many theories like diffraction, reflection, and refraction. And when we combine both this theory, we get a new branch of light, you can see, which is a quantum theory. So quantum theory is nothing but a combination of wave theory and a particle theory. So this was about the theory of light. So if you are willing to understand it more clearly, let me put you. If we do a partition in a room and a rod is pierced in between the partition, if we hit the rod at one end, what will happen? The heat energy is being transferred to the another end of the rod, and at a point will come when the rod and the end of the rod will become reddish in color as it's getting heated continuously. So it's going to glow up at some extent. So this is a particle about the particle theory. As the light is being transferred and it is being scattered as a particle. Then what about the wave theory? When the heat is being transferred, the rod over here, it will become, heated up. So that's all about the wave theory of the light. So the idea of wave light is more clear to you. So let's move ahead, which is reflection of light. I have been telling you, you have been saying that lights are being reflected over here. But what actually a reflection is? Reflection is nothing but a phenomena of bouncing of light when it hits an object. We can see these lines are incident on these objects. When the incident light hits the particular objects, it gets reflected back. That's what called the reflection is. So for the reflection, we actually need a source of light and a object. So there are many sources of light. We can go for sun, LED bulb, etc. But what about the object? Objects are mainly classified into three states, like opaque object, transparent object, and translucent object. What are opaque object? If you take an example of a stone over here, when a light is incident on the stone, it will reflect back, right? But it is an opaque object as light is not being absorbed over the stone. If you take an example of the glass, if we incident a light of ray on the glass, it will actually pass through it, right? So that's the example of transparent object. And what about the translucent object? Translucent objects are the object which allow light rays to pass through partially. You get a blurry image for the translucent object. So there are many properties of light as well: reflection, refraction, dispersion, polarization, and various ones. So there are laws of light. When a light is incident over an object, it follows certain rules. So if I here to take a mirror, a plain mirror, and if I allow a light incident on this plane mirror, it will reflect with some angle. So we actually draw a perpendicular over here, which is called a normal ray. It's just an imaginary ray. We just put on for our convenience. So it's a normal ray. So you can see that I have drawn in such a manner that this angle and this angle are equal to each other. So what I mean is the angle of incidence is equal to the angle of reflection. Angle of incidence is denoted by I and the angle of reflection is denoted by R. So this was about the first law of reflection. There are usually three laws of reflection. Second law of reflection tells us that the incident ray and the reflected ray and the normal ray lies on the same plane. The third law tells that the incident ray and the reflected ray lies either side on the normal. So so this is a plane mirror, incident ray and the reflected ray. So now we have it has been a clear-cut idea of what the reflection and light is. So let's move ahead towards the different types of mirrors and some parts of it. So far we have heard about the reflection, and you have got a basic idea of reflection. So let's move ahead towards the mirrors. So there have been from your previous standards you have been learning about plane mirrors, spherical mirrors. So let's first consider the plane mirrors over here. So this is a plane mirror actually. It's denoted by this. This is actually the reflecting surface. And the surface which is denoted by this parallel lines, this is non-reflecting surface. So for non-reflecting surface, black or blue color has been that as those colors are really bold. And for the reflecting surface, silver or aluminium was used as it was really shiny and it could reflect the lights back. And for those plane mirrors, there's not really much that we're going to learn today. So, what happens when you are listening to a plane mirror? Usually, it forms an image, right? When you see yourself in a plane mirror, it usually forms an image. So, the image which is formed in a plane mirror is same distance and of the object. The distance that you are standing in front of the plane mirror is equal to the image which is obtained. And if your height of some 5 feet, the image which is obtained is equals to the 5 feet. It's not more or less to it. And there's one more property called lateral inversion. Lateral inversion is nothing but the right side of the object appears to be the left side of the image. So there have been many benefits of using a plane mirror as we get a virtual and an erect image. Why we need a plane mirror in order to gain a erect image? So this was all about the plane mirror. So there's one thing, when the ray of light is incident on the plane mirror at the 90 degrees, it's almost a perpendicular line to the plane mirror. What happens? As we know, when light is incident on the plane mirror, it will reflect back. But what happens when the light of incident is equals to the angle of 90 degrees? It actually retraces the path. It won't get reflected into another direction. It just gets reflected into the same direction. So this was all about the plane mirrors. Now let's move on to spectral mirrors. There is a much difference between plane mirrors and spherical mirrors. Spherical mirrors, they are like bulged in or bulged out. Like the reflecting surface of this mirror is bulged in. This is a non-reflecting surface and this is the reflecting surface. The reflecting surface is bulged in. Such mirrors are known as concave mirrors. And the mirrors whose reflecting surface is bulged out. So you can see this is a non-reflecting part and this is the reflecting part. So this is the convex mirrors. So we have a wide usage of concave and convex mirrors. So concave mirrors, they are usually used in clinics, dentists, for they focus on a particular area. So you get a wide and enlarged image of that particular area. Whereas at the convex mirrors, the image formed is wide. So they are used in side mirrors of the vehicle. So convex mirrors are also called diverging mirrors and concave mirrors are also called converging mirrors. Converging means when the lights are incident on this particular region, they usually converge at one point. So this is what the convergence is. Here the light rays are converging, they are meeting at this one point. And what about the convex mirrors? When the lights are incident on this mirror, they usually get diverged, they usually get scattered. So that's the advantage of the convex mirrors, as it scatters the light in all directions. 1, 2, 3. So now we are going to learn terms related to spectral mirrors. So the center, usually this is the spherical mirror that I have drawn, and this is the non-reflecting part, this is the reflecting part. So spherical mirrors are usually a part of a big sphere, it's an imaginary sphere. So the center of the spherical mirror is known as center of curvature. It is denoted by the letter C. And the center of this plane mirror is known as the pole. Center of the spherical mirror is known as pole. And a line passing through the center of curvature and the pole is known as principal axis. It is denoted by P. So when the lights are incident on this plane mirror, they usually come and intersect at one point. This point of intersection is usually known as focus. And the distance between this focus point and the pole is known as the focal length. It is denoted by letter small f. And this radius of this spherical mirrors, the part which is the reflecting part, is known as aperture. It is denoted by A. It is aperture, and the radius of this spherical mirror, it is denoted by letter R. So there are various sign conventions for spherical mirrors. H1 is the height of the image, H2 is the height. H1 is the height of the object, H2 is the height of the image, V is the distance of the image, and U is the distance of the object. For convex and concave mirror, there are sign conventions. We need to understand those. So for the concave mirror, height of the object, for the when the image is virtual and erect, H2 is always in negative, and for real and inverted image, H2 is negative, and for the image distance, it is usually for the virtual and erect image it is positive, and for the real and inverted image it is negative. And when we talk about the U, which is the distance of the object, it is usually n minus. So this was all about the reflection chapter. I hope I helped you in some way, and I also recommend you to join this institution if you are a NEET or JEE aspirant. So it was all from my